Hi, today we'll discuss the topic parallelogram law of forces here. Okay, so this law is mainly used to find the resultant of two forces. Okay, this is applicable only for to find the resultant force if two forces are given. It is not applicable for if the more than two forces if they give, then you cannot apply this parallelogram law of forces here. Okay, first let us see the statement. Okay, statement, what it states, that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram then their resultant may be represented in magnitude and direction by the diagonal of parallelogram which passes through their point of intersection. Okay, this is the statement. Just I'll explain. If two forces, as I said, this is only applicable for two forces. If two forces acting simultaneously on a particle be represented in magnitude and direction. Let us consider the two forces here. That is, one force, it is represented in terms of magnitude and some direction, and one more force that is represented in magnitude and direction. Two forces represents in terms of magnitude and direction by the two adjacent sides of a parallelogram. It means whatever, if it is acting at a point, then you need to represent these two forces by the two sides of a parallelogram. You know the parallelogram here, that is by the two sides of a parallelogram. You need to represent two sides of a parallelogram here, like this. You need to represent. Okay. Then the resultant of these two forces may be represented in magnitude and direction by the diagonal of parallelogram. Where is the diagonal of the parallelogram here? This is the diagonal of a parallelogram. It means if you draw the parallelogram, and you are getting like this. Okay, this is the resultant. The resultant may be represented in magnitude and direction. You will get some magnitude and some direction by the diagonal of a parallelogram which passes through their point of intersection. This is point of intersection here. It means, okay, this is how the statement it will denotes here. Now let us just I will explain how the statement it will work here. Just we'll see here. Okay. You need to consider two forces. Just consider two forces P and Q. P and Q. Okay. These two forces you need to represent the two sides of a parallelogram. That is two sides of a parallelogram. As I said, this is force P, I denoted here, and this is force Q, I denoted here. Okay, this is two sides of the parallelogram. If you draw other two sides here, that is, this is one more side it will come, and this is one more side it will come. Okay, then the resultant, how it will be the resultant here? The diagonal of this parallelogram is this one. This is the resultant. This is the resultant force here. Okay, now if you want to find out the resultant force, you have some formula here. That is, resultant force, that is R equal to resultant force that will be equal to square root of P square, that is this force square, plus Q square, the one more force, the second force square, plus 2PQ into cos of theta. This is the resultant of these two forces, where theta equal to angle between these two forces. That is, whatever P and Q, the angle is there. This is the theta. This is the theta, where theta is angle between force P and Q. Okay, this is how the formula here. That is, the square root of P square, this square, plus Q square, plus 2PQ into cos of theta here, where theta is angle between these two P and Q here. Okay, then how we will find out the angle, this result? If this resultant, it will make certain angle with respect to P also, it will make certain angle with respect to Q also here. Okay, let us, if just I'll give the angle alpha is, that is alpha equal to, just I'll explain how it will there. That is tan of alpha equal to, that is, here this is P, that is plus Q cos theta divided by Q sin theta. That is numerator Q sin theta here. That is where alpha is angle between R, resultant R, and force P, that is force P. If you want the angle between R and P, then because this resultant makes an angle with respect to first force P, at that time just tan of alpha equal to, just in the denominator just make it first P here, that is with respect to P. This resultant makes an angle with respect to the P. So in the denominator write P, then Q sin theta, that is other force, Q sin theta divided by this plus into Q cos theta here. This is Q sin theta divided by Q cos theta here. Here only you need to add P here. You need to add P here. This is the angle here. This is the alpha. This is alpha. Okay. Suppose if you want the angle between resultant force and Q, then you should use this formula here. That is, you should use, that is tan alpha. How you will write? Tan alpha equal to, just in the denominator, because you are making your resultant force with respect to Q, with respect to, you want the angle here, you want the angle resultant with respect to Q, then in the denominator just write first Q plus that is here P sin theta divided by Q plus P cos theta here. P cos theta. Okay. This is how the angle. Here this angle is different and this angle is different here. You be concentrate and be careful here. If you want angle between resultant with respect to P force is there, P force, then in the denominator P it will come. The others Q sin theta divided by Q cos theta here. If you want the angle between resultant and the Q, then whatever the tan alpha is there, in the denominator first Q, you just write Q, you need to add Q, again same P sin theta divided by here P cos theta here. This is how you need to, depending upon the problem given, you need to solve, you need to use the alpha equation here. Okay.